So welcome to the lecture series on Introduction to Computer Networks. This is part two of the lecture on the topic of TCP IP model. So we're going to jump to the point where we left off. So given that we have an understanding of what the TCP IP model is, we are going to look at what the OSI model is and what it looks like. So the OSI model is similarly modular and hierarchical, and it gives us a great opportunity to conceptualize and understand protocol architectures by using the same modular view. So the OSI model has 7 layers. This is a conceptual reference for the layered network model. On the other hand, the TCP IP model that we looked at earlier is more of an implementation specific guideline for protocols. The OSI model gives us a reference, and it stands for Open Systems Interconnection Model. The layers are starting from layer 1, that is physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So how do we remember all of these? There is a trick to it. You can just remember the phrase, all people seem to need data processing. So this stands for A for application, P for presentation, S for session, T for transport, N for network, D for data link, and P for processing. Or if you want to go from bottom up, that is from layers 1 to 7, you can remember it as please do not touch Steve's pet alligator. So presentation, data link, network, transfer, session, presentation, and alligator and application. So the OSI networking model looks like this, where it has the physical layer right at the bottom and the application layer right at the top. And the way that it compares to the TCP IP model, the first version, is that the data link and the physical layer corresponds to the link layer. The network layer is the same as the internet layer, the transport, and application, presentation, and session is together referred in terms of protocol implementations in TCP IP. In the newer version of TCP IP, the link layer just breaks down into 2 different layers, the data link and the physical. The remaining parts are the same. So let's look at the functional description of each of the layers. Layer 7, which is the topmost layer, the application layer, it provides the interface for communicating between software applications. So let's say you have Skype running on one host and you have Skype running on another host. These 2 applications communicating with each other is facilitated through the application layer. The presentation layer is responsible for converting the data formats and the format in which the application layer would read the data and needs to read the data. It may include text based on the ASCII character format, binary to JPEG, anything that requires any form of encryption, so that the application layer is able to read that given data. The next layer, layer 5, is the session layer, and this defines how sessions are established and torn down between 2 endpoints. So it actually allows to have the application that is running in the upper layer to have the concept of a session which can start and end, and also we have the control features where we are defining the sequence of the messages, and also the seamless view of the incoming stream for the application. Layer 4 is transport layer, and it focuses on the data delivery between two hosts. To be very specific, it provides operations and features to include error recovery, retransmission, flow control based on the congestion status of the network. You can slow down and speed up your transmission speed and all of these services. So all of these features are together packed into the transport layer. Going further deep, the third layer, that is the network layer, is basically responsible for packet routing. So it allows you to route and forward packets, find the path that is the best suitable to reach the destination from the source, and how the packet would be delivered through that path. It also allows routers to learn routes so that it can keep in memory the paths that it is learning in the process of the transmission of packets. Next, layer 2 is data link layer, and this, just like what we have seen for the TCP IP model, in the OSI model, the data link layer defines the way a device can send data over a specific medium, the way that the two devices are connected, how these bits are going to be interpreted as they are being received, or how they are required to be converted before they are being sent over to the physical layer. And finally, the lowest layer, that's the physical layer, defines the standards for the physical transmission medium, which may include wired connections, copper wires, radio frequencies for wireless, or light for fiber optics, anything that you would use to transfer the bits, and how you can define the rules for that given physical medium. So the OSI reference model does not come with a specific implementation of these protocols. However, it does include the guidelines of which protocols would be best suited for each of these layers. For example, the application, presentation, and session layers, it corresponds to the application layer in TCP/IP, and it includes this whole set of protocols which are more application specific. The transport layer is supposed to support TCP and UDP, just like the TCP/IP model, where the TCP protocol is there to guarantee packet delivery but at a slower rate. On the other hand, UDP is faster but does not guarantee packet delivery. The network layer, the IP protocol, the internet protocol, is again the most common protocol for the internet and is the backbone of the internet, and supports IP addressing, IP routing, and it facilitates the routing of packets from source to the destination. The data link layer, borrowed from the TCP/IP model in the OSI model, the data link layer supports um, protocols such as the Ethernet and HDLC, and the devices which support the data link would be switches, wireless access points, and all of these which are responsible for end-to-end connections. And the physical layer, these are more hardware and tangible devices. The RJ45 is the most common connector port that you find for LAN cables, and anything that supports these physical medium and the connection of the physical medium uses the physical layer. So the benefits of the OSI layers, it allows us to simplify the networking the concepts into smaller parts so that we can address each individual task into separate modules. It allows you to define interfaces between each of these layers, and uh, eventually different manufacturers can develop software or hardware to support the operations for each of these separate modules. Layering makes the overall concept of protocol architectures easier to learn because they are broken down into smaller concepts and smaller details which are responsible for specific tasks. And eventually, they actually make it easier to develop because if there is a change in the software which is supporting the transport layer, for example, you can just switch or swap out the software for the transport layer and leave all the other layers untouched so that the operation of the network can proceed without without being hampered. The layering also allows multi-vendor interoperability, which means that the devices which are being manufactured from multiple different vendors can work in the same environment and the same network, given that they are fulfilling the requirements for each of these layers. And also modular engineering, which means that the development for each of these layers could proceed independent of the other layers. For example, a web browser, which is an application layer item, can work with any of the lower layer software, for example, the TCP/IP software, which is available in Windows, and it can work with it. So the concept of encapsulation that we saw in TCP/IP also exists for OSI. Uh, we refer to the term PDU, or protocol data units, uh, which starts from the application layer. So the data that is generated in the application layer, you add a layer 7 header, that is the application layer header. The whole item becomes the data for the next layer, and then you add the layer 6 header. From the layer 6, the whole item becomes data for layer 5, and you add the layer 5 header, and so on and so forth. So every layer presents a protocol data unit together with the header for that particular layer and passes it on to the next layer. And eventually, in the data link layer, you get the data from the network layer and you add the header and the trailer in the data link layer. So if you are going down, you are encapsulating the protocol data units. If you're going up, you are de-encapsulating the protocol data units so that each of these layers can interpret what it requires.